You know, you walk past these huge industrial buildings, train stations, massive factories, and you maybe don't think too much about the roofs. But they're not just sitting there. People are up there doing essential work, cleaning gutters, fixing solar panels, patching leaks. And you have to wonder, right, how did they do that safely? Hundreds of feet up, often on these big sloped metal sheets, it seems, well, incredibly risky.
So that's what we're diving into today. We're going to take a really close look at a key piece of safety tech,
Yeah.
the Horizontal Lifeline System, or HLS. Specifically, we'll focus on one called the ROOFSEIF system. We've gathered info from various expert sources to really unpack how this stuff turns super dangerous work into something, well, manageable and secure.
Absolutely. And before we jump straight into the Lifeline system itself, it's useful to maybe set the stage a bit. With the basics of fall protection, there's this concept called a hierarchy of fall protection. It's basically a framework, 5 levels, starting with the best, most effective way to stay safe down to the minimum measures.
Okay, makes sense. Lay it on us. Right, so top of the list, level 1 is eliminate. Just get rid of the hazard entirely, like using one of those long poles to change a light bulb instead of getting on a ladder. Simple, right? Avoid the height altogether.
The ideal scenario, but probably not always possible on a giant factory roof, I guess.
Exactly. Which brings us to level 2, passive protection. Think permanent barriers, things that are just there, protecting people without them having to actively do anything. So guardrails, catwalks, those little walls around some roofs, parapets, or even using a cherry picker. They create a physical barrier.
Got it. Like a permanent fence.
Pretty much. Then level 3 is restraint. This is where we start actively limiting where a worker can go, using things like permanent anchor points or, and here's where our topic comes in a horizontal lifeline system, to physically stop someone from reaching a dangerous spot, like the edge.
Ah, okay. So the Lifeline acts like a leash, in a way, keeping you in the safe zone.
In restraint mode, yes, that's a good way to think about it. Then level 4 is arrest. This is what happens if a fall does occur. The goal here is to stop the fall and minimize injury. This is your personal protective equipment, PPE, full body harnesses, lanyards, fall arresters that absorb shock, sometimes even safety nets like wire mesh underneath.
The last line of defense, basically.
Correct. And finally, level 5 is ADMI, or administrative controls. These are procedures, rules, training. Things like signs, safety briefings before starting work, rules about how many people can connect to one anchor, specifying rope lengths, using temporary anchors sometimes. It's all about managing the process.
Okay, so that hierarchy, it really clarifies things. Elimination is best, but often you can't eliminate the height on these big roofs. So the horizontal lifeline system, it sounds like it fits mainly into restraint.
And arrest. It can function in both ways depending on how it's set up and used.
Right. And it seems like it provides such a robust solution that for the workers, it almost becomes the practical way to eliminate the immediate risk, even if the height itself is still there. Okay, so let's zero in on the ROOFSEIF horizontal lifeline system then. You said it's permanently installed on metal roofs. What's its main job?
Its core purpose is pretty straightforward. Provide a continuous, secure anchor point for workers doing maintenance. They clip onto it, and it prevents them from falling. Simple concept, but quite sophisticated in practice. And there are really 3 main goals when you install one. First, like we mentioned, fall restraint. Design it so the worker attached with their standard lanyard physically cannot reach an edge or fall zone.
Okay, keeping them away from danger.
Second, fall arrest. This is the backup safety net. If someone does fall, maybe they step through a weak part of the roof or slip near an opening, and the system catches them, stops the fall, saves their life.
Right, critical.
And third, traveling. These roofs can be huge. The system needs to let workers move around, sometimes long distances, easily and safely without ever having to unclip. Continuous connection.
That makes sense. Now, you mentioned it's not one size fits all. How does the roof itself, like its slope, change how the system is installed? This sounds interesting.
Yeah, the pitch of the roof is a major factor. It dictates the whole installation strategy. For low-pitched roofs, think gentle slopes, maybe 3 to 10 degrees. The HLS usually goes around the whole perimeter of the roof. And crucially, it's set back about 2 meters from the edge.
2 meters specifically. Why that distance?
Because standard safety lanyards are typically 1.8 to 2.0 meters long. So if the line is 2 meters back and your lanyard is 2 meters long, you simply can't reach the edge.
Ah, clever. So that setup is purely about restraint.
Exactly. It functions primarily as a fall restraint system in that configuration. Now, for steep-pitched roofs, say over 15-degree slope, you wouldn't install it near the edge. Gravity's too much of a factor. Instead, the HLOS is usually installed along the peak, the ridge of the roof running from where the workers access it. On these steeper roofs, workers are often working more like climbers, rappelling or lowering themselves down from that central ridgeline to do their tasks.
Totally different way of working, dictated by the roof angle. Okay, so what are these things actually made of? They must be incredibly tough. Any surprising material choices?
Oh, absolutely tough. Durability is key. Almost everything, the cable itself, the anchor brackets, the plates, tensioners, those little gliders workers use, it's almost all high-grade stainless steel. We're talking grade 316 for cables, often 304 or 316 for other parts. This stuff resists rust, handles harsh industrial pollution, even salt spray in marine environments. Seriously, the Lifeline components are often designed to outlast the roof sheeting itself. The cable, for example, is typically an 8mm stainless steel wire, usually a 7x7 or 7x19 weave that just refers to how the strands are bundled. That specific construction gives it incredible strength. It can handle over 3 tons of tensile force, but it's still flexible enough to work with during installation.
3 tons. Okay, so the surprising part, is there one?
Yes. Here are the really clever bit, the clamps. The actual anchor device clamps that attach the system to the metal roof sheets. They're made of aluminum.
Aluminum, not stainless steel. Why?
Right. It seems counterintuitive at first, but it's vital. See, stainless steel has a higher electrical potential than the zinc or aluminum coating on typical metal roof sheets. If you clamp stainless steel directly onto that coated metal, you'd create a little battery, basically. It causes galvanic corrosion.
Ah, like on a boat hull if you use the wrong metals?
Exactly the same principle. That corrosion would eat away at the roof coating around the clamp, leading to leaks and premature failure of the roof itself. Using aluminum, a specific grade, AA Series 6000 prevents that galvanic reaction entirely.
That is smart. A small detail with huge consequences for the building's lifespan, and it probably makes attachment easier too.
Often, yes. It can sometimes allow for clamping without needing to drill holes through the roof sheet, which also helps maintain the roof's integrity. It's a really neat piece of engineering foresight.
Okay, so the materials are carefully chosen. How do we know these systems actually perform under pressure? How are they tested and certified?
Rigorously. They're designed and tested according to strict standards, primarily the European standard BSEN 795, specifically Class C for horizontal lifelines. The anchor devices, for instance, have to withstand a static load of 1.2 tons, that's 12 kilonewtons, for at least 3 minutes without failing. And dynamically, they need to handle the impact of a 100-kilogram mass falling from a height of 2 or even 2.5 meters.
That's a serious impact.
It is. And an important point here, you should never try to do load testing like that on-site after installation. Dropping heavy weights can actually damage the system components, compromising future safety.
So the testing is done beforehand, under controlled conditions.
Exactly. Key components are tested by accredited independent labs, and the overall system design for a specific roof installation is reviewed and certified by professional civil engineers. That provides independent validation that it meets the standards.
Makes sense. What about how many people can use it at once?
Good question. The standard design allows for up to 2 workers simultaneously within any single span that's the length of cable between 2 anchor devices. And on one continuous lifeline system, the maximum is typically 4 workers in total. But the key rule is never more than 2 people in one span at the same time.
Okay. And how far apart are those anchor devices?
Usually they're spaced no more than 10 meters apart, especially on common roof sheets, like the 0.60 millimeter thick ones.
Yeah.
Keeping them relatively close ensures the cable stays properly tensioned and doesn't sag too much if someone falls.
Right. Minimizing slack is key for fall arrest. Okay, so we know it's strong, reliable, certified. But you mentioned traveling earlier, moving along the line. How does that work smoothly? Especially past those anchor points every 10 meters? That sounds like it could be fiddly.
Ah, that's where the pass-through capability and the horizontal glider come in. It's really elegant. See, with older systems, or systems without this feature, if you were using a standard twin lanyard, the kind with 2 hooks, you'd have to approach an anchor. Unclip one hook, clip it onto the cable past the anchor, then unclip the second hook and clip it past the anchor. Then you could continue.
Okay, I can picture that. Sounds slow and like there's a moment where you're only attached by one hook, or maybe even briefly unattached if you mess up.
Precisely. It's time-consuming and introduces risk points. The horizontal glider, sometimes called a traveler, solves this completely. It's a specially designed component that slides along the cable. Your lanyard connects to the glider, not directly to the cable. And the glider is designed to pass straight over the intermediate anchor points without you needing to disconnect anything.
Oh, wow. So you just walk. And it slides over the obstacles.
Exactly. You stay continuously connected 100% of the time while moving along the line.
Yeah.
It dramatically improves safety and efficiency. Workers can move much more freely and quickly.
How do you connect to it?
Simple sequence. You attach your lanyard snap hooks to your harness as usual. Then you install the glider onto the cable lifeline. Then you attach a carabiner to the glider, making sure to lock it. Finally, you clip your lanyard snap hooks onto that carabiner. That's it. Continuous, safe movement.
That sounds like a massive improvement, a real game changer. But what if the job isn't right next to the lifeline? What if you need to get, say, halfway down a steep roof section far from the ridgeline?
Right. Good point. The main lifeline provides the primary safe path, but sometimes you need more reach. That's where supplementary gear comes in. One key piece is the fall arrestor block, often called an SRL, self-retracting lifeline.
Like a car seat belt.
Very similar principle, yeah. It has a drum inside, with the line could be webbing or wire rope that pays out as you move away and retracts automatically as you move closer. It keeps the line relatively taut, minimizing slack. You attach the housing of the SRL directly to one of the system's anchor devices, not the cable lifeline itself. That's critical.
Anchor device only. Got it.
And then the retractable line coming out of it connects to the worker's full body harness. Now, there are important things to know. You need an SRL that's specifically rated for horizontal use, not all of them are, and you need to choose the right length for the job. They come in various lengths, and the longer ones get heavier, obviously. A 10-meter one might be around 5 kilos, but a big 32-meter one could be 13 kilos. So you pick what you need.
Okay, so SRLs for moderate distances attached to anchors. What if you need to go even further, like way out into the middle of a huge roof section?
For those really extended distances, sometimes called Zone C on diagrams, you typically use a specialized rope with a rope grab. This involves a specific type of rope, usually a semi-static polyamide rope, about 10-11 millimeters thick, very strong, rated for at least 1.2 tons. One end of this rope is secured firmly to an anchor device on the main HLLS. The rope then passes through a device called a rope grab. This rope grab is connected to the worker's harness with a carabiner. The grab allows the worker to move along the rope, but it's designed to lock onto the rope instantly if there's a sudden pull, like in a fall.
Sounds effective, but maybe more complex to use.
Definitely. This method requires significantly more training. Because the rope is static, there's potential for slack to build up if the worker isn't careful. And slack is dangerous in a fall because it increases the fall distance and the impact force. So workers using this need to be really vigilant. Keep the rope as short and taut as possible for the task at hand.
Right. It puts more responsibility on the user to manage the slack constantly. A balance between reach and vigilance.
Exactly. It's a tool for specific situations requiring extra reach, used by properly trained personnel.
So we've got this sophisticated system, specialized attachments. What's the real-world footprint? Are these systems common? Where are they actually being used?
Oh, they're incredibly widespread, especially in industrial and infrastructure settings.
Yeah.
The impact is huge because they enable essential maintenance that just couldn't happen safely otherwise. Just to give you an idea, in Thailand alone, over 50,000 meters of these horizontal lifeline systems have been installed since around 2015. That's a lot of protected roof space.
50,000 meters. Wow.
And the client list shows the trust placed in them. We're talking major government infrastructure like mass transit lines, the blue, red, green, gold, yellow, pink lines, ensuring safety for workers maintaining those critical transport networks. Also, national utilities like the Provincial Electricity Authority, Metropolitan Waterworks.
Okay, so big public projects rely on them. What about private companies?
Absolutely. Big household names. Food and beverage giants like Pepsi, Frito-Lay, Nestle factories. Major manufacturers like Denso, Bridgestone, Michelin, Goodyear, Yamaha. Even high-end brands like Le Creuset. Chemical companies like Jotun, and large commercial centers too, like Central Plazas.
That's a really diverse list, from trains to tires to tomato sauce, basically.
It really shows the versatility and the recognized need. Anywhere you have large, complex roofs requiring regular access for maintenance, these systems are becoming the standard for safety. It allows work that's just too dangerous otherwise.
It definitely highlights how critical they are. Now, installing it is one thing, but safety is an ongoing process, right? What about maintenance and proper use? How do you ensure the system stays effective over time?
That's a crucial point. Maintenance and correct usage are non-negotiable for continued safety. First off, if there's ever any fall incident, even if the worker seems okay, the system must be taken out of service immediately.
Immediately, no matter what.
Immediately. And it needs to be inspected thoroughly by trained, competent professionals before anyone uses it again. Components might look fine, but they could be compromised. The AGI absorber might have deployed or stretched. Brackets or posts could be bent, even slightly. The cable itself might have lost tension. Only a proper inspection can clear it for reuse or identify necessary repairs or replacements.
Okay, that's post-incident. What about regular checks?
Like any safety gear, regular preventive maintenance is essential. Typically, this means a full inspection at least once a year by qualified personnel. And then there are the day-to-day usage guidelines, the do's and don'ts for the workers using the system.
Right. What are the key ones?
For the do's, definitely use the horizontal glider for smooth, continuous travel. Always attach supplementary gear like SRLs only to the designated anchor devices. Never clip them onto the cable lifeline itself. Regularly check the cable tension. It shouldn't be overly slack. And basic housekeeping, like cleaning components sometimes with an appropriate stainless steel cleaner.
Okay. And the don'ts. What should workers absolutely avoid?
Number 1, never use the Lifeline system for anything other than fall protection. Don't use it to hoist materials. Don't tie ladders to it. Nothing like that. Its only job is protecting people. Also, don't try to move or modify any anchor devices yourself that requires authorization and proper procedure. Don't step on, lean on, or sit on the cable or anchors. Treat it as safety equipment, not a footrest or handhold. Avoid exposing components to harsh chemicals like strong acids or alkalis, and protect them from welding sparks or heavy grinding dust if possible. And as we mentioned before, never attempt your own load testing on-site by dropping weights. That's dangerous and can damage the system.
That all seems like common sense, but vital to reinforce. It really drives home that even the most advanced safety tech relies on people using it correctly and respecting its purpose. This whole deep dive into the horizontal lifeline system, especially looking at ROOFSEIF, has been fascinating. It really highlights how this kind of specialized engineering, these thoughtful design choices like the aluminum clamp, create this vital, often completely unseen layer of safety. It's what allows people to do incredibly necessary work in potentially lethal environments, day after day, securely. It really is about meticulous planning, making difficult, dangerous work possible.
It really is. And, it makes you think, this raises a broader question, doesn't it, about this whole hidden world of safety systems. We see the buildings, the bridges, the factories, but we rarely see the intricate network of protocols and specialized gear, like these lifelines, that underpin their construction and maintenance. It's this vast, largely invisible infrastructure of safety that allows so much of our modern world to function. How many other ingenious solutions are out there quietly protecting the people who build and maintain everything around us in ways we never even consider? It's quite something to ponder.
That's a great thought to end on. Thank you for joining us on this deep dive into a truly critical, if often overlooked, aspect of industrial safety. Keep exploring curious topics with us.